Welcome, students. Today we'll start a new chapter, Chapter 3, Motion in a Straight Line. Fine. Before we start this chapter, we have to understand what do you mean by motion, or more precisely, we have to understand what is the difference between your rest and motion. So what is a rest? When an object is said to be rest if it does not change its position with respect to the surrounding as the passage of time is known as your rest. For example, you can take, suppose you have a table. On that table you keep your book. That is an example of a rest. Even after few days you'll check, the book will stay there. That means it hasn't changed its position with respect to its surrounding. But what is a motion? An object is said to be in motion if it changes its position with respect to its surrounding with the passage of time. You can take the example of a train. What happens in a train? The train is continuously moving forward. If it is continuously moving forward means it is continuously changing its position with respect to its surrounding. So it is in motion. Fine. Now after considering your rest and motion, let us take our next topic, point object. What is meant by a point object? If the position of an object changes by a distance much greater than its own size in reasonable duration of time, then the object is regarded as the point object. What does this mean? Whenever an object covers a distance which is much greater than its size, then that object will be regarded as a point object. For example, you can consider our Earth. Earth. Okay. Now why Earth is a point object? It is a point object because as you can see, what does the Earth does? It takes a revolution around the sun. What do you notice is that this Earth covers a very large distance. It covers this distance which is much larger than its own size. Such objects are regarded as your point objects. Fine. Now, on the basis of motion, we can categorize motion in three basic categories. The first category will be when an object can move only in a straight line. Let us consider this object, or let us consider this blue one as your train. Now what does this train does? This train can move only in this straight line, or I can say this train can only move on the rail track which is straight. So either it can go forward or either it can go backward. Such kind of motions are your one-dimensional motion. Let's take a look at the another one, two-dimensional motion. Suppose this is your table. Okay, on this table, suppose you have a marble. This is your marble. Now your marble can move anywhere on this table. Either it can move here or either it can move here. Either it can move left or right, or either it can move up or down. So such kind of motions will be your two-dimensional motion. Why two-dimensional? Because it can move only along two axes. This will be your x-axis. Either it can move forward or it can go backwards like your train, or either it can move along its y-axis. That means either it can go up or either it can come down. Such kind of motions are your two-dimensional motion. Now coming to our last kind of motion, that motion will be your straight line, or sorry, it will be motion in a three dimension. Now what does this mean? It means, before we do, let us consider this one. Okay, this is my x-axis, this is my y-axis, this is my z-axis. Fine. Now whenever a body can move along my x-axis, it can move along my y-axis, or it can move along my z-axis, such kind of motions will be an example of a three-dimensional motion. Fine. Let's take an example of a kite. This kite can move either front or back. It can move up or it can move down, or this can come towards you or it can go away from you. So can you see, it can move along plus x, minus x, it can move along plus y, minus y, and it can move along plus z and minus z. Such kind of motions will be your three-dimensional motion. Fine. Now whenever a body is in motion, it covers some distance. So moving to our next topic, distance and displacement. So distinguish between the terms distance and displacement. Distance, or it is also known as path length. It is the length of the actual path traversed, means traveled by a body between its initial and final position. Fine. What does this mean? It means, let us suppose this point is my A, this point is my B, this point is my C. Suppose you have a object at point A. Fine. The object moves from point A to B. It then moves from point B to C, and then it moves from C to A. Fine. Then how much distance it has covered? It has covered the distance A to B, AB plus this distance B to C, BC, and then C to A, CA. This is the length which has been traversed or traveled by this red object, and this is known as your distance or your path length. Now your distance is a scalar quantity. What does a scalar quantity means? It has only magnitude, no direction. Okay. To understand this one, consider this one, this example only. Now in this case, you see your object first moves from here to here, then from here to A, right? It has moved from A to B, B to C, and then C to A. Fine. Now the body or this red ball can also move from A to C, again from C to B, and then finally back to A, B to A. Now in this both the cases, the body has traveled the same distance. So it doesn't matter in which direction it moves, but the distance it travels or the numerical value or your magnitude will be same. So I've said whenever a quantity which has only magnitude or your numerical value or your number and no direction, then that quantity is known as your scalar quantity. So a distance will be a scalar quantity. Fine. Distance is a scalar quantity. Now the SI unit of distance is meter. We denote it using small m. The CGS unit of distance is centimeter. We denote it using cm. Fine. Now let's move to the another one, displacement. The displacement of an object is the change in the position of an object in a fixed direction. Fine. It means again let us consider this point as A, this point as B, this point as C. Fine. Now consider you have a object at point A. Consider you have a object at A. Whenever this object changes its position, let us say it has moved from A to point B, then this change in position in a fixed direction is known as your displacement. Fine. It is the shortest path measured in the direction from the initial point to the final point. Okay. To take a clearer picture or to distinguish between your distance and displacement, let us consider example. Suppose you have a object. This object has moved from this point to this point. Fine. So this is the red line which you see is the distance traveled by the object. Okay, but now consider your object here. Okay, this object can also change its position like this, isn't it? It can move in this direction. Now this will be your displacement. And again, what did I say? Displacement is the shortest path. See, it is the shortest path. We don't have to consider the long one. We have to consider the short one. It is the shortest path measured in the direction from the initial position to the final position. Fine. Now, unlike your distance, the displacement depends upon the direction. Okay, let's take this example. In our example, what happened? For the distance example, a body was at A, it moved to B, then B to C, isn't it? Or let us say we consider only this one. Suppose you have a body. Okay, this body which starts moving from A, it goes to C and then C to B. Fine. Now, how much distance it has covered? It has covered the distance A to C and B to C. This is the distance covered by the object. Fine. But what will be the distance covered by the object? Distance is again the shortest path measured between the initial and the final position. What is the initial position? A. What is the final position? B. So this distance will be the displacement. Displacement will be AB. So do you notice what happened? Here, the distance can be measured in any direction. Fine. The distance traveled can be measured in any direction. But to measure the displacement, it has to be measured only in this direction. And then only you will get a displacement. If I had measured my displacement from here to here, from here to here, would I have been correct? No. I have to measure the displacement only in this direction. Fine. So, whenever a quantity has a numerical value and a direction, then such quantities are called as your vector quantity. And since your displacement has a numerical value, means it will have some distance plus it is measured along some direction, then this displacement is also a vector quantity. Fine. Now the SI unit of displacement is meter and the CGS unit of displacement is centimeter. Fine. Now let us take a look at some characteristics of a displacement. Now the displacement of an object can be positive, negative or zero. What does this mean? Okay, to understand this one, let us consider this first figure for positive displacement. Consider you are standing at position A. Fine. You are standing at a position A and you have a pole in front of you at position O. The distance between the A and O is x1, or I can say the distance between you and the pole is how much? X1. Now after some time you have moved to a certain distance. Let us say you have moved to the point B, or the position of point B is how much? X2. if x2 is the position of the B, what will be the distance between the pole and the position B? X2. Fine. Now what is displacement? Displacement is the distance between the displacement is the distance between the initial and the final point. Okay, so in this case, what was your initial point, or I can say the difference between the initial and the final point? This is your initial point x1, which is your final point x2, and the difference between your initial and the final point will give us displacement. Fine. Now in this case, x2 minus x1, as you can already see, x2 is bigger than your x1, so this is an example of a positive displacement. Thus, whenever you'll move in this direction, you will have a positive displacement. Fine. Now let us take another example. Let us consider initially you were standing at position A. Now you have moved to a position B. Now in this case, what happens? What is the final position? X2. And what is your initial position? X1. So the difference between the initial and the final will give you the displacement. Now in this case, which quantity is bigger, x1 or x2? X1. Thus what you are getting? A negative displacement, which means when you move in this direction, then you have a negative displacement. Fine. Now coming here, the last case. Suppose you were standing at point A. Fine. After some time you have moved to point B, and then you have again returned to the point A. Fine. So what was your initial position? X1. Or what is the initial distance? X1. What is the final position? You are still at A. And what will be the final position or your final distance? Again, x2. So when I subtract x2 minus x1, or when I find the difference between them, what it will be? 0. That means in that case, there's no change in the position. Fine. So that's it for today's class. If you have any confusion, you can ask me. I will re-explain it to you again. So thank you.